Yes, so today we discuss about the chapter continuity and differentiability. So in this first I'll explain that NCERT board level programs. After completion of this, just we'll discuss about CET model questions, MSET and previous CET and MSET questions and mains and advanced level questions also. But in this first we discuss about that continuity. So what is the definition of continuity and how to check it? Continuity means when we say that the function is continuous, when we say that the function is not continuous. Not continuous is nothing but discontinuous. Okay, so first we discuss what is the exact definition of continuity or continuous function. Okay, so now this is part 1. So coming to definition, so here this is one of the given function f maps a to r. If you want, just write let f maps a to r be a given function. In sometimes we can written as a real valued function. Okay, be a function or be a real valued function. Clear? And small a belongs to capital R. And now this is the condition for each epsilon greater than 0, then there exists a del greater than 0 such that 0 less than mod of x minus l less than del implies that mod of f of x minus f of a less than epsilon. If the given function f or f of x satisfies this condition, then we say that f of x is continuous function at the point a. Then f of x is called continuous function at the point x equal to a. So that is limit extends to a f of x equal to f of a. What is the meaning of this? Limit equal to value. Okay, if limit equal to value, then we say that the function is continuous function at the point or at the given point. Okay, and again that is left limit equal to right limit equal to value. Clear? And point is a na? So symbolically how to write this one? Limit extends to a minus f of x, and coming to right limit, limit extends to a plus f of x equal to value means f of a. Okay, so but when we find left and right limits and when we find the limit to value, so if we take this example, so here this is first example. Suppose f of x equal to 2x plus 3 and x equal to 1. This is the given function. Function is f of x equal to 2x plus 3. Point is x equal to 1. Nothing but x equal to a. See, in this only function is given. Of course, point is also given. In this case, no need to find left and right limits. Directly we write limit and value. Directly we find both. Okay. Now what is the point here? 1. So at x equal to 1, limit, how to write this? Limit extends to a, but a is equal to 1, f of x. Clear? that equal to limit x tends to 1. What is f of x? 2x plus 3. So how to write this one? 2 into 1 plus 3. So 2 into 1 is 2. 2 plus 3 is equal to 5. And coming to value, so what is the point here? Actually, formula is f of a, but a is equal to 1. Then how to write it? Again, substitute x equal to 1 in the given function. So 2 into 1 plus 3. So 2 plus 3 is equal to 5. Then what is the conclusion for this? Therefore, limit x tends to 1, f of x equal to f of 1. Means limit equal to value. That implies f of x is continuous, clear, yet x equal to 1. So this is the example. And coming to second example, so just I am writing here only. F of x equal to x square at x equal to 0 is given. Clear? Now here also same function point is given. So just we find limit and value. Got it? Then how to find limit at x equal to 0? Limit, right? This is limit. Limit x tends to 0, f of x. That is limit x tends to 0. What is f of x? X square means 0 square equal to 0. And coming to value, so how to write it? F of 0 that equal to 0 square. Again it is also equal to 0. So therefore limit x tends to 0, f of x equal to f of 0. That is limit equal to value. That implies f of x is, what is that? Continuous, yet x equal to 0. If limit is not equal to value, then we say that the function is not continuous or discontinuous. Clear? Now this is third example. Discuss the continuity of the function f given by f of x equal to mod of x at x equal to 0. So how to prove this? Now what is the given function here? F of x equal to mod of x. I mean modulus of x. And there is one definition for modulus of x we studied in first year. Clear? What is the definition? So set of x comma if x greater than or equal to 0 minus x comma if x less than 0. Clear? So less than or greater than is given. Then we find the left limit, right limit, value. If all are equal, I mean left limit equal to right limit equal to value, then we say that f of x is continuous at the point x equal to 0. Otherwise discontinuous. Clear? So just write here at x equal to 0. So first we write left limit LL. So how to write this? Limit x tends to 0 minus f of x. That is limit x tends to 0. In this two, which is for left limit? X less than 0 is for left limit, right? Why? Because suppose if you take direction line here, if you take 0, here we'll get 1, 2 and so on infinite. And this side minus 1, minus 2 and so on, it is minus infinite. X less than 0 means this part, negative part, right? And this is positive part. So less than 0 is nothing but left limit. So here this is the function for left limit. Then what is that? Minus x. Minus 0. Minus 0 can be written as 0 only. And now we find right limit. So how to write this one? In bracket RL. Right? So limit x tends to 0 plus f of x. That is limit x tends to 0. If it is for left limit, then this is for right limit. What is that function? X. So 0. Now what is the meaning of this? Left limit equal to right limit. So limit of a function is exist. If both are not equal, then we say that limit of a function does not exist. In that case, no need to find value. When left limit equal to right limit or right limit equal to left limit, then only we find value. So here just write value. So it is f of 0. So x equal to 0 is here na. Again substitute x equal to 0. Then it is also equal to 0. Then limit extends to 0. F of x equal to f of 0. Then what is the meaning of this? F of x is continuous yet x equal to 0. This is the answer. Got it? Now this is example number 4. Show that the function f given by f of x equal to, first case is x cube plus 3 if x is not equal to 0. Second one 1 if x equal to 0 is not continuous at x equal to 0. Clear? So not continuous means what is the meaning of that? Limit is not equal to value. Got it? So what is the point here? First write given function, given that f of x equal to x cube plus 3 if x is not equal to 0, 1 comma if x equal to 0. So now at the point x equal to 0, so first we find the limit, right? How to write this? Limit extends to 0 f of x. So that equal to limit extends to 0. What is the function here? X cube plus 3. If we write, if we substitute, if you put x equal to 0, we get 0 cube plus 3. That is 0 plus 3 equal to 0. 0 plus 3 is how much? 3 na? That 0 plus 3 is equal to 3. And coming to second one, what is that? Value. So it is f of 0. What is the functional value here? F of 0, x equal to 0, f of x equal to 1. Then if we substitute 0 here, f of 0 that is equal to 1. But what is the relation between these two? Limit extends to 0, f of x is not equal to f of 0. Therefore, f of x is not continuous at which point x equal to 0. That is the answer. This is example number 5. Check the points where the constant function f of x equal to k is continuous. So here constant function is given, right? What is that function? F of x equal to k. And now just write let x equal to a belongs to r. Just we find limit and value na. So how to find limit? Limit extends to a f of x. That is limit extends to a. What is f of x? K. Then we get k. Clear? And coming to second one, that is value. So value means f of a. It is also equal to k. So limit extends to a, f of x equal to f of a. That implies f of x is, what is that? Continuous at which point? X equal to a. A is real number. In some place you can substitute a equal to 0. In that case also we get k only, limit and value. If a equal to 1, both are same. A equal to 2, both are same. A equal to 3. So for any value of a, limit, value both are equal to k only. Then we say that it is continuous function at the point x equal to a, where a is belongs to r. Clear? Now this is example number 6. Prove that the identity function on real numbers given by f of x equal to x is continuous at every real number. Okay. So first we take one real number, either a or c. We show that the function is continuous at that point. So if it is continuous at that point, at every point a given function is continuous. Then finally we read that conclusion. Clear? Now see what is the given function here. Given that f of x equal to x, let x equal to a belongs to R. So just we find limit and value, right? Limit extends to a f of x, that equal to limit extends to a x, where x equal to a na, just write here equal to a. Next value, that is f of a, it is also equal to a. So therefore limit extends to a, f of x is equal to f of a. What is the meaning of this? F of x is continuous at x equal to a. If it is continuous at x equal to a, then for every real number it is possible, na? So just write that is the final conclusion. Therefore f of x is continuous for all real values of x. That is the final conclusion. Now this is seventh example. It is same as example number 3. We already discussed it. But in that, what is the condition? F of x equal to mod of x at x equal to 0 is given. But here point is not given, but we'll take same point. Why? Because that is the standard definition of mod of x. Okay. Now what is the definition? What is the given function here? F of x equal to modulus of x. So first one is x. If x greater than or equal to 0. Minus x if x less than 0. Same as example number 3. No changes. So right here at x equal to 0. So less than and greater than is there. Na? Just we find the left limit, right limit. If both are equal, then we find value. Otherwise not required. Okay. So first we write left limit. How to write this one? Limit extends to 0 minus f of x. That equal to limit extends to 0 minus x is for the left limit, right? Then it is equal to minus 0, that equal to 0. Now right limit. Limit extends to 0 plus f of x. So limit extends to 0 x. This is for right limit, right? It is also equal to 0. So left limit equal to right limit. Na? LL is nothing but left limit, RL is nothing but right limit. Okay. So now we find value. Value means f of 0. F of 0 x equal to 0 is here, substitute 0 in this place. Then we get 0. So what is the meaning of this? Limit extends to 0. F of x equal to f of 0. Therefore, f of x is continuous at x equal to 0. That is the answer. This is example number 8. Discuss the continuity of the function f given by f of x equal to x cube plus x square minus 1. Only function is given, point is not given. Then we consider 1 point, we'll take 1 point. Okay. So how to prove this? Given that f of x equal to x cube plus x square minus 1. Next, let x equal to a belongs to R. Okay, so point is a. First we find limit. Na? How to write this? Limit extends to a f of x. That is limit extends to a. What is f of x here? X cube plus x square minus 1. That is a cube, a square minus 1. Okay, then value. So value means what is that point? A. Na? Then we find f of a. So f of a means how to write this? Again x equal to a cube, a square minus 1. Therefore limit x tends to a, f of x equal to f of a. That implies f of x is continuous at x equal to a. Not only point a, you can take any point, either C or B or D, any point you can consider. But at that point only we should find both limit and value. If both are equal, then we say that continuous function, otherwise not continuous. Not continuous is nothing but discontinuous. Clear? Now this is the 9th example. Discuss the continuity of the function f defined by f of x equal to 1 by x comma x not equal to 0. So x not equal to 0 means we can take any point other than 0. Okay. So given that f of x equal to 1 by x comma x is not equal to 0. Let x equal to a. Just we find limit and value at this point, right? So it is limit x tends to a f of x. That is limit x tends to a 1 by x. That can be written as 1 by a. And coming to second one, what is that value? Na? So how to write it? F of a. Again that can be written as 1 by a. Therefore, limit x tends to a f of x equal to f of a. So both are equal, limit equal to value, right? Then what is the meaning of this? F of x is continuous yet x equal to x. That is the answer.